Hello everyone, I am Mario and welcome back. So in this video we're going to talk about how to model basically anything. So I'm pretty sure that everybody had this question asking how can I model anything that I see, how can I model this or that. So in this video we're going to cover at least the key elements necessary to master to actually model anything that we want to. In addition, I've written a extensive text or an article, and I'm going to link below the description or in the comments where you can read that if you want to. I'm going to probably add a bit more visual examples if I miss something in this video, but it's going to just cover maybe a bit more things that I haven't covered in the video. So I understand that starting with 3D modeling can be very overwhelming, especially if you're a beginner. So there's a lot of information to absorb, and I know that not all the sources will share exactly the same information. So just think of it as a kind of like a road trip. So we know where to go, but we actually maybe do not know which turns to take. We need sometimes just the help of the map or navigation just to tells us what is the best and the fastest route and which turns actually could lead us to our destination faster. So sometimes the road will be unfamiliar and the trip might be long, but this is only for the first time, because the second times we will start to notice familiar signs and stops and so on. So with modeling, it's really similar thing. We're just going to use various guides as often as possible until we're confident enough so that our skill kind of evolves to the point that we can actually model anything that we want to. Before we actually dive any deeper, let's just do here a small breakdown. So if we were to split the modeling skill or the modeling in general, what would be the key elements that we would need to master? So if I would need to put this in 3 groups, that would be understanding the modeling tools, understanding the modeling principles and topology, and then understanding design flow and function. So once we understand the tools, topology, form, function, and translating our ideas into 3D will be very straightforward. So let's now see how we actually can get there. First thing that is going to be very important is going to be the understanding of the general tools and simply the commands, operations that I use in 3D modeling software. So the good news here is that even if you learn, let's say, modeling tools in Blender or Maya or Cinema 4D, you can easily translate that knowledge into another software, simply because, let's say, that we trying to use bevel to bevel sharp corners and add sharp corners, actually add more smoothness to the sharp corners. The bevel operation is going to work exactly the same in Blender, Cinema 4D, as you've seen it work here. So the operation in general is going to be the same, just adding smooth corners to sharp corners, for example. Same thing is going to be with the extrusion. So let's say if I want to extrude this object and if I want to add more geometry here, I simply need to use the extrude operation. The same thing again is going to be applied in Blender, Cinema 4D, because the extrude operation will always work the same. Now, why are the tools so important and why we actually need to get familiar with the tools before we actually can make anything? So once we know the tools, we can then understand how we can use the combination of the tools and do something from it all. So in this case, we used extrude and we used bevel. So if we use, let's say, these in combination, so let's say I'm now using extrude with the boolean, with the bevel actually, we're now using 2 operations in combination with one another to create the desired result that we want to. So again, this is going to be very big factor for us, simply because we need to plan ahead everything that we're going to do. So before we even begin modeling, we need to know what tools, what operations or commands will help us to deliver the most optimal results. That way we can be productive with our modeling and also save time in the process. So for example, before starting on a project, we'll also have we'll just need to have answers to questions like how to do a shape lockout, how can I progress from one shape to another, or how to advance basic shapes into new and more complex shapes. So these will be the questions, and we are going to need to have answers to those before even starting 3D modeling. So for that purpose, we are going to need to be very familiar with the tools, how the tools operate. All right, so now that we know the importance of the modeling tools, let's see why we actually need to understand topology. And so for tools, I didn't have so many examples because this is more or less like straightforward tools. Obviously, we need to know, but again, we need to be very familiar and also very comfortable in knowing them. So the next thing on our list is going to be understanding 3D modeling principles and topologies. So as we explore the modeling tools, probably gonna get familiar with the terms like polygons, edges, vertices. So this is going to be a polygon, this is going to be an edge, this is going to be a vertice. And then depending on how the structure looks like or how it's organized, this is something that we're going to refer as topology. So topology here can be either a good topology or it can be bad topology. And this simply means that the good topology is going to be the one that it's very predictable. It's going to be easy to operate. It's just going to be much easier also to manipulate. On the other hand, we're going to have bad topology. This is going to be something that it's very difficult to organize. It's not going to be as predictable. So meaning that, let's say if I want to select here a loop, I can go anywhere I want to and I can select the loop. Here I cannot really do that. As you can notice, is not really that, it's not easy to predict where the loop is going to end. So like mentioned, the way polygons, edges, and vertices are organized, we're going to refer to as topology. So topology, like we mentioned, can be categorized as good or bad, depending on if we organize edges, polygons, or vertices on our surface. And the modeling principle is simply a method that helps us define the shapes while maintaining this good topology. So same as modeling tools, modeling principles are very universal, and whatever you learn in one software, this is going to be translated into others. So there's also that question. So I'm using Blender. Can I follow my tutorial? So yeah, of course. So you can follow any kind of tutorial that is connected to modeling topic regardless of the software. So the general principles that it's going to be learned in 3D modeling, this is something that's going to be translated in any other software. So what are these 3D modeling principles and what makes them really so important, and why do we actually need to understand topology to model anything? So modeling principle will consist, I would say, out of two very important factors. So we're going to focus on edge flow and edge direction, or edge control. So edge flow is going to be this. So when you can see the edges, how they're flowing, this is going to be your flows. And edge control is simply going to be controlling the edges into our advantage. So I'm going to show you an example of this here. So here we have an example of the edge flow. All right, so let's define what edge flow is. If I would need to explain it in the most simplest way, I would say the way the edge loop flows along the surface, we are going to call edge flow. So this would be our edge flow. And then later, as a result, the flow of the edges will manifest as a highlight on our object. So we can see an example of this right here. So I can actually isolate this one. And here we can see highlight. And here is going to be maybe more visible. Here's going to be our edge flow. So this is the flow of the edges, and then this flow is forming the highlight. By manipulating the flow of the edges, we are going to determine the highlight we're going to get. So now I'm just changing a bit of that edge flow, so it's no longer flowing so close to the neighboring edge. So now it's a bit further apart. And the moment we put something further apart, we're going to get more of a smoother highlight. So why is this important to us? So this is something that we're going to manipulate later just to get the highlights we want to. And then by knowing the highlights, then we're going to also easier break down the object. So it sounds very simple in theory, but where things get a bit more complicated is where we actually need to maintain the flow while also maintaining the object. So here I have two examples, and as you can notice, they have very different highlights on their surface. So on one side, so this is going to be the left one, the edge flow is going into this direction, and it's sort of like messing up the geometry. So technically the flow is here, but it's messing up the geometry and we are not maintaining the shape that we want to. On the other hand, we kind of have here the same thing. So we want to, let's say, create this detail, and this detail is from here to here. And the similar detail can be found here, but let's say Now, let me just select everything here. The thing about this detail is that it's actually standing pretty good on the surface and the surface is maintained. So this is what I mean, just that with the flow of the edges, we're also going to just need to be sure that once we manipulate the flow, that we're also maintaining the shape of our objects. So if we lose the shape of our objects while changing the flow for the sake of the details that we're trying to do, then this is going to be not a good thing for us. So in the end, it's very important to understand that the flow needs to be controlled while maintaining the clean topology and not impacting the surface. So this is going to be very important to this. So in the end, similar to where we need to plan the tools ahead, so in addition, we also need to plan the edge placement. So the reason for that, again, is very simple. Edge placements will form the flow, which will define the highlights like we've seen right here. So it all comes down to this. So why is this important into modeling anything, and how can that help us actually to create or recreate anything? Well, if we know the highlight, then we can also know what the edge flow behind that highlight is. And if we know what the edge flow is, then we can also easily recreate that object. So I'm going to show you that here in practice and how would that look like. So one of the biggest questions is going to be always how can I begin with an object, where to even begin, how to, like, also the question from beginning that we had on Discord is, if I would to break down the object to a simple primitive, how could I find where is that primitive? So here we have very basic examples, and what I show you here, this is also going to translate into more complex stuff as well. And that is, if you know the highlight, you know the edge flow. If you know the edge flow, you can guess the primitive. So here, what I would like to just quickly demonstrate, so we're going to go into Photoshop real quick. We have here the same thing in Photoshop. And what basically, before trying to model anything, like we mentioned before, we would need to understand the tool set so that we know what tools are we going to use. So in our case, we need to probably know the tools to create objects, to create cuts, to create extrusions, bevels, and actually making highlights. Once we know that, we can also understand better which tools to use to create the operations that we're going to talk about here. So like we mentioned, if we know the highlight, then it should be pretty easy to break down the flow. And if you break down the flow like this, so basically what you're trying to do here is just sort of like draw on the surface the best you can. What do you think the flow would look like just by tracing the highlights? So in our case, this would be, if I again just take here something, if we would need to trace the highlight would be this, and then the highlight will be this right here. And then we just need to connect everything that comes in between those highlights and solve the edge flow. So this is something that, again, it will take time, but again, finding the highlight, defining the edge flow will also help you understand, again, which object to start with. So in our case, this is going to be a clear cylinder. So the same thing here on the other side. So if you were to define the highlight here, the highlight is going to follow the main shape, and then the only thing is we need to do is kind of like find the general points. So let me also make this a bit higher so it's easy to understand. So general points where the mesh breaks. So this is where the mesh breaks. So this is where you would see the highlight. And once you know the mesh breaks, then this will be your connection, as you can see here. And then after that, it's just going to be very easy to fill out all the gaps and maybe solve the flow. So you just fill everything then in the middle to do a proper flow. So it would be, let's say, something in the middle. But this again comes later after you know the highlight. And once you know the highlight, you just draw the form as best as you can to see which primitive would fit the best to the form that you just drawn out. So this is a very simple object, but the same thing will apply if this objects would be very complex. So this is something that you can also find on YouTube. This is part of the KitBash library practice. So if you wish, you can also check the complete process. It's right here on YouTube. But the same thing would apply here. So what would be the approach to break down this object? And again, just drawing the basic shapes. So just tracing the highlights. So again, you can notice just tracing the main highlights. Ignore every single detail. Details not matter, detail come later, and they're not relevant to creating the shape. So first things first, we're just defining the shape based on the highlights that actually is defining that shape. So this would be that main highlight. If you want to make things even more easier for you, you can also create solids out of all that, just to draw out and see what shape that would be, so that you can easily recreate that. So in our case here, probably we'll just use the regular cube, flatten it out, and then extruded this top part that it's found here. And then this would be very easy to create that shape. And then later, once you have that, you can go ahead a bit more, just break it down and see what connections you would need for details. For example, this detail right here. If you're not sure how to do specific details, this is also going to mention later, do a small case study. So if you're not sure, do not start modeling the whole thing. Just focus on this one part, start with a cube, and what do you think how this detail would be. And then only later, once you know the flow around this, then you'll be able to, let's say, add a Boolean operation with the cylinder, cut this out, and then connect the proper geometry. So it's easy to plan your projects ahead like this. So this can be for really any type of project. So if you start with something really big and you're not sure where to begin, try to just draw it out and see what would be the basic shapes that you can get out of the highlights that actually are defining the shape. So ignore the details, ignore everything else, just the general shape. And then later, once you know that, then you can break it down even further and see how to do. So for example, this is now the cylinder. Even though that it has this connection in the back, it still would be that beginning primitive would be a cylinder. And then that cylinder, you can either then connect the sphere on the back, or even if you want to, you can then start with the sphere, extrude it. But again, this is just that planning. This is how you just plan ahead and think about the terms of the tools that you want to use and the approach. So like I mentioned, you can either start with the cylinder and then connect the sphere later, or simply start with the sphere, then extrude the sphere to get a cylinder. Additionally, again, the more experience you get, you're going to understand that once you subdivide a cube, let's say, that you're going to get spherical topology. And once you have that, you're going to have very clean topology to start. So you might also start with a cube, subdivide it 2 more times to get spherical-like looking shape, extrude that part, and then you get cylinder with clean topology in the end. So it's really a lot about part of building the experience, and then just breaking down your projects before you even start working on them. So this is why the topology part is going to be very important, understanding how the edge flow works, because we are going to understand where to redirect edges, direct edges, and how to form specific highlights. So this is now connecting to the edge flow. So we covered the tools are going to be important, because we need to know ahead of time which tools to use. And then second thing, we need to know the topology, because we need to simply know how to break down the highlights and which flows to use to get the desired highlights. The third key element is going to be understanding the design and functions. So we talked about planning and preparation in terms of we need to break down the object, look for the highlights, look for the edge flow, plan which objects to begin with, plan which tools to use to get there faster. But this is not actually where the project begins. The planning of our modeling already starts with the design and function. So how can understanding design language and function help us actually model anything? So if we understand the object's function or purpose, we can better explain the design. So if we understand the design choices, translating any object into 3D will be that much easier. So to make things easier, here's an example. So this is going to be called more or less like synergy that determines the design. So we're going to take a car as an example. So here I have a lot of concepts, and this is made by CT31 and Behance if you want to check it out. So here's a great example that I wanted to showcase. So let's say we are modeling a car, and we are trying to model car out of our own imagination. So we know that the primary function of a car is transportation. So let's say that the car design has no doors. We cannot enter or sit inside. So in this case, the car design will contradict the function. So there has to be a way to sell the design somehow. So like in this case, for example, we're going to see that there are no doors. So as a modeler, this is going to be a concept. You need to solve the situations that are maybe not presented in this concept. So let's say that I'm now a beginner and I would like to model this car right here. I need to predict that the doors will need to come here somewhere, because the doors are going to be very, very important and integral part of the function. So concept is, again, just a concept, is an idea. But as a modeler that is going to transfer this into 3D, we need to predict what the function of the car is going to be. And if we do not know what the function of the car is, probably we're going to model everything as is and totally ignore that there is even doors and that doors needs to be built in. Same thing, let's say, as with the steering. Same principle will apply to materials. If the brakes were made out of paper or suspension out of plastic, so the car would probably fall apart, and in that case the primary function would contradict the design again. So again, just to summarize, if you will, let's say, model this concept, which this is, as a concept, is a great concept, shows a lot, and again, a lot of stuff later is going to be solved in modeling. If we forgot to build in the doors, so if we forgot to model the doors, then the function will just contradict the design. Another example of this is going to be a weapon. So let's say that we are modeling a weapon for a film or a game, and we do not do our research, and we simply start modeling the weapon how we think that the weapon is. So here I have two examples. One example is where the weapon is completely made out of one piece, and again, here the design contradicts the function, because we all know that the function of the weapon is going to be you need to have a trigger to fire the weapon, and you need to have some kind of opening that's the projectile needs to exit somewhere. In this case, we do not have a trigger and we do not have any kind of opening, and everything is built out of one piece. So that again simply means that real weapons are probably not going to be built out of one piece. Instead, they're going to be built out of multiple pieces to allow some kind of a function. So in the second example, we have here multiple pieces that somehow explain the function, but again, the key elements are still missing and the key elements are still being ignored. So this still looks like a weapon, can be sold as a weapon, but will it function as a weapon? Probably not. So again, before starting any project, we just need to be sure that we understand the general function of how everything works before we even start modeling, if you want to create a very, very realistic image of what we are actually trying to model. So in short, we will base the form on function. The synergy between the two is what defines the design. Let's come back to the car example, and now we're going to talk about how to use the function to our advantage. And let's say, based on the information that we talked here, how would you actually recreate a 3D model of a car? So before we begin, we would gather a lot of reference that could actually explain the car's function as a whole or just its parts. So furthermore, we would search for answers to questions like, are we modeling a street car or are we modeling a terrain car? If it's terrain car, what is the engineering behind its role that supports its function? So or how the engine parts were built. Are they singular pieces or complex pieces made out of many smaller pieces? Or why do brake calipers look the way they do? Or do they have some kind of function, or is the design random? So also an important thing, why Ferrari is looking like a Ferrari? So what key design separates Ferrari from every other car, and why is it so, let's say, recognizable? So if you would see it on the street just by lights, you would know that this is a Ferrari. So I'm guessing that there is the key element to the design that we need to research why is it like that and also translate it into our modeling so that we also translate the key language of the Ferrari if we're, let's say, modeling a Ferrari, not just focus on the general concept and, let's say, start modeling there. So doing proper research is going to be very, very crucial, and these would be some of the questions to answer before even starting with modeling. So knowing the answers will greatly increase the chances of creating a proper 3D model representation. And once we understand the real world function, we can focus on translating the design into 3D. So we could go even further. So we could adjust the design the way we wish based on already established principles of function. And when we talk about principles of function, let's say that the thread patterns of a tire are designed to disperse water so that the tire and the road would maintain contact. And then let's say the design of the brakes will allow the distribution of airflow and support cooling, and the car design in general will just, let's say, be there for better terrain adjustment or aerodynamics. So you're gonna notice that the sports car have very, very different and very close to the ground design as terrain cars. So terrain cars have, again, different function, therefore different type of design. This will just be a very, very important factor. So when the design complements the function, it's just easier to break it down, introduce new ideas from existing or imaginary sources. So I just hope that that makes sense. And once we know the rules, it's easy to see which ones we can break and use into our advantage. So finally, then we can maybe answer the question, so how to model anything. Mastering the tools, the topology, and the synergy of form and function that define the design provides us with the experience necessary to model anything we want. So this is in general it, and like I mentioned, I will share the article that I've written and might answer some questions in general. But here I will just give you a few final tips before you start working on any projects of your own. So references. This is going to be very, very important. So before you model anything, just arm yourself with a lot of references on how things work and what is the purpose or function they perform. So whatever, let's say you're trying to model a weapon, just make sure to, again, find a lot of references of a weapon you're trying to model, see what purpose it is, what function does it perform, and for what reason. Second thing is going to be case studies. So let's say that you're modeling a robot and you're not sure how to model arms or hands. If you know that in advance, that hands are your weakest spot, do not start building a robot from scratch and then get stuck on hands. Do hand studies, do 5, 6, 10 examples of how you would approach hands, do anatomy studies, and then transfer that into your own design, and then try to build your own robot. That's gonna save you a lot of time. So break down the most complex pieces of whatever you're trying to model. If you feel you might struggle with some parts of the model, isolate those parts and do case studies. Third tip is going to be sketch your topology. So if you're not sure about the topology flow or where to begin, sketch the flow to plan your steps. Break down the forms into multiple pieces if necessary. If that part shows to be difficult too, try to practice on smaller, singular, and easier objects before moving to any complex parts. So, and finally, explore the tools. Just take the time to explore the tools. It's not necessary to know all of the tools, but having a solid understanding of at least the basic ones will already be a big plus. So yeah, this covers it for this video. In case you have any questions, feel free to ask in the comments below. I'll answer them if I can. And yeah, that is all for this video. I hope you find this helpful. And yeah, thank you for watching, and I'm going to see you next time.